Welcome back to The Explainer. So, you're here because you really want to understand the inner workings of our digital world. Well, you're in the exact right place. Today, we're taking the concept of multimedia and completely demystifying it. We're going to explore the invisible architecture that actually makes all of this digital magic happen.
Here is our roadmap for today. We're going to decode multimedia's DNA, look at the evolution of hypermedia, dig into the blueprints of the web, explore metaphors for building media, check out the art of presentation, and finally, peek into the future of automation. Let's get right into it.
Okay, part one. Let's dive into decoding multimedia's DNA.
For a lot of people, multimedia is just a cultural buzzword. They think of like a PC with a sound card or maybe interactive cable TV. But it's actually this massive convergence of really complex computer science fields: graphics, computer vision, data compression, and networking. And when you strip away the consumer hardware specs, you see how these interconnected modalities solve real, massive human problems. We're talking telemedicine encounters over high-speed networks, augmented reality that blends graphics perfectly with real-world lighting, and distributed interactive lectures. It even powers what researchers call inverse Hollywood tools. These are software programs that can literally analyze and automatically summarize a video or prune a storyboard just by understanding the content. It's absolutely crucial stuff, not just a toy.
Moving on to Section 2, the evolution of hypermedia.
So, how did we actually get here? To manage all this complex data, we have to look back at the history of nonlinear information. It really starts right after World War II, back in 1945. An MIT scientist named Vannevar Bush envisioned this thing called the Memex. It was a personalized memory device built on associative links, basically the conceptual granddaddy of the World Wide Web. Then, fast forward to 1965, and Ted Nelson actually coins the term hypertext while working on his Xanadu project. And then, of course, 1989 hits. Tim Berners-Lee proposes the World Wide Web at CERN. And the irony is just fantastic here, right? He literally only created it to help nuclear physicists organize and share their experimental results, and the idea just spread like wildfire and changed the entire world.
Ted Nelson actually described his Xanadu hypertext project as a magic place of literary memory. I just love that phrase. It gives such profound emotional weight to the technical origins of hypertext. You see, they weren't just trying to build a faster filing cabinet. They were trying to solve the incredibly complex human problem of managing associative thought. They were essentially mapping human memory right onto machines.
All right, Section 3, Blueprints of the Web. So we have this dream of hypermedia, but how do developers actually architect these digital spaces? Well, every time you browse the web, you're using a stateless architecture called HTTP. Your computer asks for data, the server replies, and the connection just drops. It's exactly like a phone call that hangs up the exact second you get your answer. Traditionally, we used HTML to display that data, but HTML is pretty rigid. It's mostly just for basic document formatting. That's exactly why developers shifted toward XML. XML gives you this modular flexibility. It lets a developer define custom tags using a document type definition, which completely separates the raw underlying data from how it ultimately looks on your screen.
But here's the catch. The crucial point is that neither standard HTML nor XML naturally understands time. And multimedia? It absolutely needs time. Enter SMIL. That's the Synchronized Multimedia Integration Language. It's an extension of XML that finally layers time into these blueprints. Using really simple tags, SMIL schedules and synchronizes temporal media elements. It allows for parallel or sequential playback of video and audio that perfectly reacts to user interaction. It is, quite literally, the markup language of time.
Which brings us to Section 4, Metaphors for Building Media. Having the language is one thing, but how does a creator wrap their head around building a complex, interactive project? Well, developers use physical metaphors to manage the interactive chaos. You've got your linear slideshow metaphor, the hierarchical metaphor, which is kind of like a menu tree. There's the card or scripting metaphor, think Apple's old HyperCard with a stack of index cards. But the cast, score, and scripting metaphor is what relates directly to the digital animations you see every single day. Programs use a theater metaphor where the media elements are basically a cast of characters, and time is laid out horizontally on a score or timeline. It's a lot like reading a piece of sheet music.
And then there's the iconic flow control metaphor. Instead of staring at endless lines of scripting code, a developer drags and drops graphical icons that represent logic or media. These nodes encapsulate complex information into abstract frames. It brilliantly takes the highly abstract theory of interactive subroutines and grounds it in a visual reality you can actually see and manipulate. You're literally drawing the flow of the user's experience.
Let's move into Section 5, the art of presentation.
So we've built the structure, and we've organized the logic. But what does the end user actually experience? This is the visual presentation mathematics layer. Presentation isn't just about making things look pretty. It's deeply rooted in human visual dynamics. For instance, sans serif fonts, like Arial, thrive in darkened projection rooms, while serif fonts, like Times New Roman, become a real chore to read. And when it comes to color, developers aren't just eyeballing what looks good. They are calculating exact mathematical opposites. By taking the maximum color value of 1 and subtracting the red, green, and blue values, literally 1 minus R, 1 minus G, 1 minus B, they pinpoint the principal complementary color. This math guarantees that if your background is super dark, the text is optimally bright and perfectly readable.
And it doesn't stop at text. Even video transitions are pure math. Think about a simple video wipe. It's not movie magic, it's linear algebra. First, you select your transition type, like a cross dissolve or a dither. Then, you calculate exactly where the transition boundary is at any given fraction of a second. Finally, you literally just have one set of pixels overwrite the other, copying them to new viewport coordinates. It's this incredibly energetic story of pixels just pushing other pixels out of the way, frame by frame, coordinate by coordinate.
If you were to look at the raw pseudocode for this, it perfectly maps out that geometry. You can see the math for one moving video frame sliding in from the left to replace the video on the right. As time goes by, the transition boundary moves right across the screen. The code is calculating precisely which x and y coordinates from the source video need to be copied into the viewport. It's the invisible geometry governing the video you watch on your phone every single day.
And finally, Section 6, the future of automation.
Now here's the big question. With decades of multimedia content already out there, how on earth do we manage the sheer volume of legacy media? The answer is automation. Manually creating a true, nonlinear hypermedia document is totally exhausting, so researchers are stepping up and creating automated helpers. These systems extract semantic content by masking specific areas within an image to automatically form delineated object nodes and anchors, basically creating a true hyperimage. The system identifies the objects in a picture and automatically generates hyperlinks to other parts of a database. It brings the magic of text hyperlinking directly into the pixels of a still image. A real game changer.
Which leaves us with this final, provocative thought to consider. We've seen how multimedia is built from the ground up, from its historical DNA encoding blueprints all the way to the raw mathematics of its pixels. But as artificial intelligence and automated authoring tools learn to mask, link, and generate media on the fly, how much of the media you consume will soon author itself? It's a fascinating invisible architecture, and it's evolving faster than ever. Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.